Imagine just a single drop of water. It falls high up on a mountain peak, right? And it starts this incredible journey. It meets other drops, makes a tiny trickle, then maybe a stream, and soon it's part of this huge, powerful river, carving through mountains, shaping whole valleys, and finally, flowing out into the ocean. That one drop becoming a river, well, that's kind of what we're talking about today with India's water systems. Welcome to the deep dive. Today, we are tracing that journey. We're really getting into India's absolutely fascinating drainage system. Our mission really is to explore it all. From the basic ideas, like how water even flows across the land, to the big differences between the major river systems, the complex patterns they make, and maybe most importantly, how we as humans interact with them, how we manage them. Think of this as your way to get, well, really well informed about a key part of India's geography and how it shapes pretty much everything life, culture, development. Expect some surprising facts, maybe a few aha moments about something we usually just take for granted, water just flowing. Okay, so let's unpack this a bit. Before we jump into the massive rivers of India, maybe let's get the foundational term straight. So a drainage system. At its heart, it's simply the network, right? The channels water flows through, like the Earth's plumbing, sort of.
Exactly. It's the pathways water takes.
Then there's the drainage basin or river basin. That's the whole area of land, isn't it? Everything that drains water into one specific river and its tributaries.
Precisely. Like a giant natural funnel collecting all the water in that area.
And separating these funnels, that's the water divide.
An elevated bit of land, like a mountain range or just some higher ground, that acts as a boundary. Water flows one way on one side, the other way on the other.
In a watershed, is that just a smaller basin?
Pretty much, yeah.
Yeah.
It's often used for smaller areas, maybe in hilly places, a smaller unit within a larger basin.
Yeah.
And, this is where it starts getting really insightful. These units, from the tiny watershed up to the huge river basin, they're the building blocks. They aren't just lines on a map. They're dynamic zones, places where water actively shapes the land and supports life. Understanding them is key to the whole story.
Okay, here's where I think it gets really interesting. Rivers don't just flow randomly, do they? They follow these distinct patterns, like nature's artwork. So what actually shapes these patterns?
Well, it's all about the arrangement of the main river and its tributaries. And that's heavily influenced by the land itself, the topography, the type of rock underneath, the geology, any faults or folds.
Right, so the land dictates the pattern.
In a big way, yes.
So let's look at some specifics then. The most common one you mentioned is dendritic, or vrikshakar.
That's right, dendritic. Think of a tree.
Like branches.
Exactly like branches spreading out.
Yeah.
It happens where the rock structure is pretty uniform, so water can just carve its way fairly evenly.
Okay, and examples would be?
Oh, lots of the big peninsular rivers, actually. Godavari, Mahanadi, Kaveri, Krishna. They show this pattern really well.
Gotcha. Then there's trellised. Jalanoma, that sounds different.
It is quite different. Here, the main rivers and their tributaries tend to flow roughly parallel to each other. But the tributaries often join the main river at almost sharp right angles.
Right angles. Why?
It's typical where you have folded or faulted land. Imagine ridges and valleys running parallel. The main river follows the valley, and tributaries cut down the ridges at sharp angles. You see this in parts of the Himalayas.
Okay, folded land. Makes sense. And rectangular ayatakar. How's that different from trellised?
Similar idea with the angles, but maybe less uniform than trellised. You get these really angular bends, often close to right angles, but maybe not as consistently parallel. This happens where the rock is heavily jointed or faulted, like big cracks in the rock that the water follows.
Ah, like following cracks.
Okay, the Vindhyan Mountains are an example.
That's a good example, yeah.
All right, moving on, radial, arraya. That sounds like radiating outwards.
Exactly, like spokes on a wheel. Rivers flow outwards from a central high point, a dome, a volcano, a distinct hill.
Okay, like from a single peak.
Yeah. A great example is Amarkantak Mountain. You have the Narmada flowing west, the Sun flowing north, Mahanadi flowing sort of southeast, all starting from that same general high area.
Wow. And the Damodar, too. The Damodar, starting from the Hazarabad Plateau, is another good example of a radial pattern.
Okay. And the opposite of that, flowing in.
That's centripetal, or epicondria. Rivers flow inwards, converging on a central low point, like a basin or a lake.
Loktak Lake in Manipur.
Perfect example. All the streams drain into the lake. It's the reverse of radial.
Now, this next one sounds really intriguing. Antecedent drainage. Purvavarti Apwa, you said? A river cutting through a rising mountain. How on earth does that happen? It sounds impossible.
It does sound impossible, doesn't it? But what's fascinating is that these rivers are actually older than the mountains they cut through.
Older.
Yeah, imagine a river flowing across a relatively flat plain. Then, very, very slowly, over millions of years, the land starts to uplift right in its path, forming mountains. But the river has enough power, and it erodes downwards just as fast as the land is rising. So it just keeps cutting down, maintaining its original course.
Wow. It just refuses to be diverted.
Exactly. Geological stubbornness, you could call it. The Indus, the Brahmaputra, the Sutlej, the Kosi, and the Himalayas, they all did this. That's how they created those incredibly deep gorges.
That is amazing. Okay, and the last one. Superimposed drainage. Adhyopit or Purav Nimit Apwa.
Right. Superimposed. These rivers seem to kind of ignore the underlying rock structure they're flowing over now. They establish their path on an older upper layer of rock. Then, as erosion removed that upper layer, the river just kept cutting down, maintaining its course, even when it encountered different older rock layers below. It looks like the pattern was just placed or superimposed onto the current geology.
So it's like a ghost of an older landscape's drainage pattern.
In a way, yes. And many of the peninsular rivers show characteristics of this. They seem quite indifferent to the rock types they cross in places. And really, if you connect this to the bigger picture, these patterns are like fingerprints of the Earth's geological history. A dendritic pattern might tell you about ancient, stable land. Trellised or rectangular patterns hint at faulting geological action. Antecedent drainage tells an amazing story of uplift. It tells not just where rivers are, but how the land itself evolved.
So putting it all together, when we look at India's drainage overall, it basically splits into two huge systems, right?
Yeah.
Each with its own kind of personality.
Two main groups.
The mighty Himalayan rivers and the ancient peninsular rivers, a tale of two giants.
Absolutely. Young and energetic versus old and steady, in very broad terms.
Okay, let's start with the Himalayan drainage system. You said young.
Geologically speaking, yes. They're still actively evolving, still carving out their valleys.
Then they flow all year round. Perennial.
That's a key feature. They get water from melting snow and glaciers high up, plus monsoon rains. So they have a continuous supply.
And that continuous flow, plus the steep slopes, gives them the power to cut those deep gorges we talked about.
Exactly. Features of youthful rivers in mountainous terrain.
The Indus River system is a prime example then. Starts way up near a Kailash range in Tibet, over 4,000 meters high.
That's right, staggering altitude, 4,164 meters. And it flows for, what, about 2,880 kilometers in total?
Yeah, huge distance, with around 700 kilometers or so actually within India.
And it's not just the Indus itself. It has these maybe tributaries, the Sutlej, Beas, Ravi, Chenab, Yalum, the Panjnad rivers, each one significant.
Which immediately brings up the issue, doesn't it? This is a massive river system shared between countries. How does that work?
Yes, a critical point. That leads us to the Indus Water Treaty.
The 1960 treaty between India and Pakistan.
Correct. It basically allocates the waters. India gets unrestricted use of the eastern rivers, Ravi, Beas, Sutlej, about 20% of the total water.
Which are vital for Punjab, Haryana.
Crucial for irrigation there, yes. And Pakistan gets the bulk of the water from the western rivers. The Indus, Jhelum, Chenab. It's a complex but enduring agreement.
Okay. Next big one. The Ganga River system. You said largest in India.
By far. In terms of the basin area, it drains over 860,000 square kilometers. That's more than a quarter of India's total area. Huge.
Wow. And its source?
The Gangotri Glacier, specifically a spot called Galmukh in Uttarakhand. Altitude around 3,900 meters.
And the river itself is about 2,500 kilometers long.
2,525 kilometers, yeah. It flows through Uttarakhand and UP for about 1,100 kilometers, then Bihar, then West Bengal. You can really see its character change along that journey.
Turbulent in the mountains, then this vast, wide river on the plains.
Exactly.
And tributaries. The Yamuna is a big one.
The Yamuna is its largest right bank tributary, joining it at Prayagraj. But there are many others. Gomti, Gagara, Gandak, Kosi coming from the north, the Sun coming from the south.
And you have to mention the Damodar, right? A tributary of the Hooghly, which itself is a distributary of the Ganga.
Absolutely. The Damodar, famously known as the River of Sorrows, historically because of its devastating floods in West Bengal.
But that led to a major project.
It did. The Damodar Valley Project, one of India's earliest multi-purpose river valley projects, was conceived specifically to control those floods, generate power, and provide irrigation. It was a landmark project, really.
Right. Okay, the third major Himalayan system, the Brahmaputra, starts even higher up.
Yes, from the Chemyangdung Glacier, also near Kailash in Tibet. about 5,300 meters elevation.
And it's long, too, almost 3,000 kilometers.
Total length is around 2,900 kilometers, with about 880 kilometers flowing through India.
And it has different names.
It does. In Tibet, it's the Tsangpo, flows eastwards for a long way. Then it takes this dramatic turn south into India, entering Arunachal Pradesh, where it's called the Dihang or Xiang.
And then it becomes the Brahmaputra.
Once it's joined by the Dibang and Lohit rivers in Assam,
Yeah.
it becomes this massive braided river, very wide, carries a lot of silt.
And then it goes into Bangladesh.
Into Bangladesh, where it's known as the Jamuna. It merges with the Ganga, called the Padma there, and they form this huge delta before flowing into the Bay of Bengal. It's an incredible journey across different landscapes and names.
Okay, so that's the Himalayan systems. Now, let's shift gears to the Peninsular River system. These are older, you said? More stable?
Generally, yes. They're much older geologically than the Himalayas. Their courses are more graded, more settled. They tend to follow the overall slope of the Peninsular Plateau, which mostly tilts towards the east.
And their flow is different too, right? Not perennial.
That's the main thing. They are primarily rain-fed. Their flow depends heavily on the monsoon, so they're seasonal or non-perennial. Water levels can get very low, or some smaller ones might even dry up outside the rainy season.
So shorter courses compared to Himalayan rivers, shallower valleys.
Typically, yes. Their valleys are broader, shallower, more mature. They've had a lot longer to erode down to a stable profile. And their evolution, it's tied to things like the uplift of the Western Ghats way back, some faulting and rifting, and the general tilting of the peninsula.
Right. Let's look at the main ones. Most flow east into the Bay of Bengal.
The vast majority do, yeah, following that eastward tilt.
The Godavari system is the biggest peninsular river.
It is, often called the Dakshin Ganga, or Ganga of the South. Originates near Nashik in Maharashtra. Flows about 1,465 kilometers. A really major river for the Deccan.
Then the Mahanadi starts in Chhattisgarh.
Yes, flows for about 851 kilometers. Very important for Odisha.
The Krishna also starts in the Western Ghats near Mahabaleshwar.
Correct. Flows for about 1,401 kilometers. Another major artery for the southern peninsula.
And the Kaveri starts in the Brahmagiri Hills in Karnataka.
Yes, flows for about 800 kilometers. Known for being a bit more reliable in flow than some other peninsular rivers because it gets rain from both the southwest and northeast monsoons. And famous for the Sivasamudram Falls.
Ah, yes, one of the first hydro projects in India.
Indeed.
Okay, but not all flow east. There are major ones flowing west into the Arabian Sea, too.
There are primarily two large ones, and they're quite unusual.
The Narmada.
The Narmada. Starts at Amarkantak Hills in Madhya Pradesh, same area as the Sun and Mahanadi, but flows west.
Through a rift valley.
Yes, that's key. It flows between the Vindhya and Satpura ranges in a geological trough, or rift valley. Flows for about 1,312 kilometers. It's a very significant west-flowing river.
And the Tapti, or Tapi, flows parallel to it.
Pretty much parallel, just south of the Satpura range, also in its own rift valley. Starts in Bitul district, MP, flows for about 724 kilometers, also emptying into the Arabian Sea.
So we've outlined these two huge systems, Himalayan and Peninsular. Let's really nail down the differences. What truly sets them apart? Why should you, listening, really grasp these distinctions?
Okay, yeah, this is the core comparison. What really differentiates them?
Let's break it down. First, origin. Big difference, right?
Massive difference. Himalayan rivers. High peaks, glaciers, snowmelt. Peninsular rivers. Plateaus, hills, mostly rain-fed springs.
Then the nature of flow.
Himalayan. Perennial. They flow year-round because of snowmelt plus rain. Peninsular. Seasonal. Flow peaks dramatically during the monsoon, then drops off significantly.
Which affects their course in valleys.
Absolutely. Himalayan rivers. Long courses, still actively cutting down so deep, V-shaped valleys, gorges. Think youthful landscape.
Peninsular rivers.
Shorter courses generally. Much older, more stable valleys. Wider, shallower, more graded. A mature landscape.
And erosion.
Himalayan rivers, with their high gradients and large water volumes, cause intense erosion, especially in the upper reaches. They carry huge amounts of silt.
Peninsular rivers being more graded and seasonal.
Much less erosion overall. Their sediment load is generally lower.
Okay, what about when they reach the sea? Deltas.
Big difference again. Himalayan rivers, like the Ganga and Brahmaputra, build enormous deltas because of that huge sediment load they carry down to the flat coastal plains. Peninsular rivers, especially the east-flowing ones, form deltas too, but they're generally smaller. And the west-flowing ones, like Narmada and Tapti, form estuaries, not really deltas, partly because they carry less sediment and the coast drops off more steeply.
Right, estuaries. And finally, meanders, winding back and forth.
Himalayan rivers, once they hit the flat plains, like the Ganga in UP and Bihar, tend to meander extensively. They shift course, form oxbow lakes. It's a very dynamic floodplain.
Peninsular rivers.
Much straighter courses generally, less prone to meandering, reflecting the harder rock and more stable landscape they flow through. So yeah, you put all that together: origin, flow, valley shape, erosion, deltas, meanders. It paints a picture of two fundamentally different river regimes shaped by totally different geological histories and climates.
It's fascinating how geology and climate create such different water worlds within one country.
It really is, and it shapes everything around them. Now, while these huge systems get most of the attention, India has countless smaller rivers too, right? And lakes. They're important locally.
Absolutely vital. Can't forget them.
So, smaller rivers. You mentioned the Damodar, again, historically the River of Sorrows, now managed. What other significant smaller ones flowing east?
Well, there's the Subarnarekha, the Baitarani, the Brahmani, all flowing into the Bay of Bengal, draining the eastern plateau regions.
And flowing west into the Arabian Sea, besides Narmada and Tapti.
You have rivers like the Sabarmati and Mahi in Gujarat. And then there's the really unique Luni River in Rajasthan.
Unique how?
It's a case of inland drainage. It starts in the Aravalli Hills, but it flows out into the desert and basically just disappears into the salty marshes of the Rann of Kutch. It never reaches the sea.
Wow, it just vanishes. That's pretty amazing.
It is, yeah, a classic example of drainage in an arid region.
And lakes. India has an incredible variety, doesn't it? From
Yeah.
huge freshwater ones to salty ones. What are some highlights that maybe show their diversity or ecological role?
Oh, the variety is stunning. You've got Wular Lake in Kashmir, largest freshwater lake in India, formed by tectonic activity, so a geological story there.
Tectonic, okay.
Then Sambar Lake in Rajasthan, the largest inland salt lake, a completely different environment.
And Chilika Lake in Odisha.
That's the largest brackish water lagoon in India. Hugely important for biodiversity, especially migratory birds. Coastal ecosystem.
You mentioned Loktak Lake in Manipur earlier for the centripetal pattern.
Right. Largest freshwater lake in northeast India, famous for its fumdis.
Fumdis, what are they?
They're these incredible floating islands of vegetation, soil, organic matter. People even live on them. A unique ecosystem.
Floating islands, okay. Any other standout?
Well, there's Lonar Lake in Maharashtra, a crater lake formed by a meteorite impact thousands of years ago. Very unique origin.
A meteorite lake.
Yeah. And down south, Vembanad Lake in Kerala. It's the longest lake in India, a brackish lagoon system, famous for the Nehru Trophy snakeboat race. Big cultural significance, too.
So these smaller rivers and lakes, they're not just dots on a map. They're critical for local ecosystems, biodiversity, fishing, tourism.
Absolutely. They underscore the fact that water resources are vital at all scales, not just the giant rivers.
Right. Okay, so understanding how these rivers behave over the year, their regime, is obviously crucial for managing water. And speaking of management, India has undertaken some truly massive water projects, hasn't it?
Monumental ones, yes.
So river regimes first. How do Himalayan and peninsular rivers differ in their yearly flow pattern?
Big difference, again, linked to their source. The Himalayan river regime shows high flow during the monsoon season, July to September, because of the rain, but also significant flow during the summer melt season earlier, say April to June. So sustained flow for a longer period.
Okay, snowmelt plus monsoon.
Exactly. The Peninsula River regime, on the other hand, is almost entirely driven by the monsoon. So you get very high flows from maybe July to October, but then the flow drops dramatically in the dry season, sometimes becoming a trickle between March and June, much more peaky.
And this massive fluctuation in the peninsular rivers, plus growing demands, that must pose huge challenges for water usability.
It raises huge questions, definitely. How do you manage a resource that's abundant for a few months and scarce for the rest of the year? Especially with growing populations, industrial needs.
And pollution issues.
Pollution is a massive factor, degrading the quality of the water that is available. Plus, climate change impacts are uncertain, but likely to make rainfall patterns more extreme. And on top of all that,
Interstate disputes.
exactly. Sharing water from rivers that cross state boundaries is a constant source of complex, often heated disputes, managing quantity, quality, and allocation. It's incredibly challenging.
So to tackle some of this, especially the supply and control aspects, India built these huge multi-purpose projects, not just for irrigation, right?
No, that's key. They're designed for multiple benefits: irrigation, yes, but also flood control, generating hydroelectric power, providing drinking water, sometimes navigation, recreation.
They really aim to reshape the river's function.
Pretty much, yeah. Harnessing its power and regulating its flow.
Can you give us a few major examples from the source material?
Sure. There's the Bakra Nangal project on the Sutlej. Huge dam, vital for Punjab, Haryana, Rajasthan.
The Damodar Valley project we mentioned, taming the River of Sorrows.
Right, on the Damodar in Jharkhand in West Bengal. Then the Hirakud project on the Mahanadi in Odisha, one of the longest dams in the world.
The Nagarjuna Sagar project on the Krishna River.
Benefiting Andhra Pradesh and Telangana, yeah. And the huge, often controversial Sardar Sarovar project on the Narmada.
Multi-state involving Gujarat, MP, Maharashtra, Rajasthan.
That's right. And you can't forget the Indira Gandhi Canal project. Not a dam project in the same way, but a massive canal system taking water from the Sutlej and Beas rivers, from the Harik Barrage deep into the Thar Desert in Rajasthan.
Transforming the desert, essentially.
A massive feat of engineering, absolutely. Aiming to make the desert bloom. And, what's fascinating here is the sheer scale of ambition, trying to harness nature on this level. But this also inevitably raises really important questions.
About the impacts.
Exactly. Environmental impacts, submergence of forests, effects on biodiversity, social impacts, displacement of people, changes to traditional livelihoods. It forces this difficult conversation about balancing development needs with environmental sustainability and social justice. These projects are never simple.
A very complex balancing act. And looking ahead, there was that even more ambitious idea, the Ganga-Kaveri link.
Ah, yes, the grand interlinking of rivers proposal, connecting northern Himalayan rivers with southern peninsula rivers. Visionary in scope, but hugely debated in terms of feasibility, cost, and ecological consequences. Still very much a concept under discussion.
So quite a journey we've taken then, from tiny streams to these vast river systems, Himalayan and peninsular, with their unique patterns and behaviors. We've looked at the geology shaping them, the water they carry, the life they support, and the huge human efforts to manage and control them.
From basic definitions to massive engineering projects, yeah.
So as you, our listener, think about this incredible, vital network of water flowing across India, here's a thought to leave you with. With everything changing the climate, the growing population putting more pressure on resources, what do you think is the single biggest challenge facing India's water future? And maybe, just maybe, could some of the most innovative solutions come not just from more big engineering, but perhaps from understanding and working with the complexity, the resilience of these natural river systems themselves? Something to mull over, that delicate balance between using water and conserving it for the future.